One method of collecting data is through surveys. So we can do a survey of the entire population, which is called a census, or we can do a survey of a small subgroup of the population. That would be a sample survey. So a census isn't always possible to do. For example, if I were manufacturing chocolate bars and I needed to test the quality of the chocolate bars, well, if I did a census and I tested the quality of every single chocolate bar I produced, I wouldn't have any products left to sell, right? So it's not always possible to do a census, and sometimes it cannot be very accurate to do a census. It may be difficult to get a hold of everybody in the population. You may have to train a number of interviewers, and they might not all behave in the same way. That can cause small differences in the results that they each obtains. It's also a very long process to do a census, and so a sample survey is much faster. Think about doing the US Census, right? That we only try to do that once every 7 years because that takes so long and is so involved to get that feedback back from every single member of the US population. We use random sampling to try and get a subset of the population that is representative of the population that we're trying to measure. A parameter is a characteristic of a population, and a statistic is a variable measurement of the sample. We typically use Greek letters to denote parameters, mu for the mean, sigma for the standard deviation. We're going to talk about the correlation coming up, but we use, this is the exception to using the Greek symbols for populations. We use a P for a population proportion. We use the Latin letters for statistics, except again, with the proportion, we use P hat for the proportion. A biased sample does not represent the population. Some examples or types of biases, there could be selection bias. A selection bias would occur when we don't sample correctly to produce a representative group of the population. Non-response bias is where some of the people that we tried to contact maybe did not respond to us for one reason or another. And response bias is where people respond other than how they truly feel. For example, if you were to ask, suppose that I wanted to survey college students about their drug use, and I, as their instructor, and asking them, did you use drugs in the last 6 months? Well, they may not respond honestly to me. They may have a certain image that they want to maintain for their professor. And so that would be an example of a response bias. They're responding differently than the truth because they want to maintain an image, and that's just one example. There could be a number of reasons why people would respond differently than a true value. A simple random sample is one where everyone in the population has an equal chance of being chosen for the sample. The simplest way to do that is to get a sampling frame, a list of everyone in the population, and then use a random number generator to randomly select some of the people on that sampling frame. Now, sampling variability or sampling error is the differences that we will see among taking results from different samples. Think about it this way. If I asked you and 3 other classmates how much time you spent studying for the exam, your average together would probably be one value. And it would differ than if I asked 5 other random students. Now, all of these would be close to what or make up what the average for the class is, but taking small groups would produce a natural variation. So even though we use the word error, it doesn't mean anything's wrong there. It just means differences in the measurement based on having different samples. Now, a stratified random sample is where we divide the population into strata, groups, and then sample from each group. For example, let's say that I wanted to know about a new policy at Valencia. I might stratify people based on their semester in college. If they're in the first 3 semesters of college, I'd consider them in one strata, they're freshmen. And if they're in their last 3 semesters of college at Valencia, they're sophomores. So I would put them in the separate strata, and we might look at their experiences differently. So some of the results, some of the advantages are listed here, right? We can classify the results by the groups. We may have a reason why different interviewers work best with different groups. And we can stratify in such a way that there's little natural variability within each strata. A good way to think about this is, think about if I wanted to test out like a new weight loss drug. Maybe I want to stratify people by how overweight they are. Less than 20 pounds, between 20 and 50, and more than 50 pounds overweight. Why would I want to do that? Because people who are only 20 pounds overweight are probably going to lose significantly less weight than people who are more than 50 pounds overweight, just by the fact of the amount of weight that needs to be lost. So I could reduce the variability within each strata by grouping them, and that would better allow me to see how the drug actually works for different individuals of different weights. Now, a cluster sample is where we divide the population into groups and then randomly select some of the groups and sample everyone in that group. For example, if I wanted to know people's satisfaction with an airline, I might group or cluster by flight and then randomly sample 20 flights and ask everybody on that flight their experiences. Now, one thing we have to be careful about here is bear in mind that people in a cluster may have something in common. So there may be some similarities we need to account for. Systematic sampling is where I sample in the same position across my sampling frame. So maybe I sample every 20th person on my list, or I ask every 5th customer that walks into the store. That would be a systematic sampling. Now, some problems with surveys. Well, there's voluntary response bias. People who have strong opinions are the ones that tend to voluntarily respond to a survey. Think about all the internet surveys that you've seen on the internet. Unless you really are motivated by it, you probably don't fill out that survey. We can take a convenience sample. A convenience sample is just, grabbing people that are easy. If I wanted to know about experiences in Valencia, I could easily survey my class. But these types of surveys do not generalize to a larger population. You guys all in my class may not have the same experience as other Valencia students. Using an incomplete sampling frame would be problematic if we don't have an entire list of the population, then we may miss an important segment. Non-response bias, well, when people choose not to respond to a survey, they may feel vastly different than the people who do respond. So that could be problematic in our results. And then, of course, response bias. If there are factors about the survey or the questions or the interviewer doing the questions that cause people to respond differently than how they really feel, then we're not getting a true result for our survey. And this little cartoon in the textbook gives us an example of that.